and then we basically have covered all of the functions, okay? Sinusoidal, though, is kind of like a special case altogether. And here you have the graph of a portion of a sinusoidal function. But what can you guess if I were to go as far left on the axis? What would you observe? What do you think you would observe? If you start here, you go like this, you go like this, it's going to continue, right? The same pattern. I'm going to be contained. There's a restriction at the top and there's a restriction at the bottom, so you stay within that. It doesn't change, okay? It's cyclical, it repeats, and that's why sinusoidal functions are special, okay? So they're cyclical, pattern repeats, the range is always restricted. And it doesn't have to be a word problem for the range to be restricted. It's restricted no matter what, okay? Just like a quadratic function, a parabola, is restricted in the range, right? It doesn't go negative infinity to positive infinity. It's restricted. So sinusoidal function is also restricted. So set calculator to radians. We already did that, okay? So that's very important for you to observe that. The domain here would be unrestricted. If it's not a word problem, we would go negative infinity, we would keep seeing this pattern, or positive infinity, okay? So let's dive in. Let's flip the page. And first, I just want to talk about this. You don't really need to understand it a whole lot because we're just going to work with the radians all the time. And radians, this is what radians allows us to do in math, okay? It's an alternative way to express the size of an angle. What do you know angles as? Like you've always studied them in degrees, right? Angles were always degrees, and now we have a different measure, and it's called radians, okay? And so you basically want to think of a circle having 360. And what does 2 pi remind you of? What is the circumference of a circle? Circumference of a circle distance around is 2 times pi times radius, right? If you have a radius of 1, if you have a radius of 1 meter or 1 centimeter or whatever, so if r is equal to 1, then circumference is just 2 pi. The distance around is 2 pi, okay? So this is kind of like the idea where everything is coming from, knowing that if the radius is 1, the distance is 2 pi. So I'm going to go way down at the bottom of this page, somewhere in here. I'll just show you this, okay? If this is your dot that you're starting from and you make a reference line, this would be my 0 degree line, okay? And if we measure from there, it would take us, well, it would take us 90 degrees to get to here. Okay, that'd be 90. Another 90 gets us to 180 out here. So if you want to put the 90 up here, that's probably better. Okay, so this would be 90, another 90 is 180. Another 90 here would be 270. And going back to the origin is 360, right? So 0 or 360, we're still saying we're back here in this position, right? So 90-degree increments, right? Same thing with a circle. If you think of a circle, okay, if you want to say this is 0 radians, all the way around is what we call 2 pi radians. 2 pi. What is 2 pi approximately equal to? 6.28. So did you know that you can say, hey, You made a 360 or you made a 2 pi. You're actually saying the same thing, just in different units, okay? Hey, can you do a 2 pi for me real quick? You can kind of throw that in there. Anyways, so what about, so if full circle is 2 pi, then all the way to here is what? Like half a circle would be just pi, right? So pi is half a circle, 2 pi is a full circle. So radians is simply, this is your radians. Same here, this is radians. So you're, instead of saying an angle of 180 degrees, you can say this angle has, right, the angle is pi, which I know you're thinking like, that's just weird, right? I know that, and I'm not gonna dwell on this too much. I'm just letting you know that we're leaving the degree, we're leaving degrees behind, and we're always dealing with radians. So if our calculators are set to radians, that is what the calculator is using in the background. Okay? Keep going. Okay, let's go to this page right here. This is something that your study sheet should have no questions asked, like that big formula you see there, the big equation. Okay. When we deal with data that appears to have repeating pattern, okay, so if data has a repeating pattern, and you notice that there's a cycle, we call them periodic functions, okay? Sinusoidal functions, right? Any periodic function whose graph has the same shape as that of y is equal to sine of x. So that's what a sinusoidal is in particular. We all know that, what is the other one? There's sine and then there's cosine. Did you know that you can also have a cosine function, right? We're not going to ever deal with cosine. It's always going to be sine, okay? Sinusoidal, that's all we deal with in this course. Period, the amount of units along the x-axis for a full cycle, okay? That is, usually it is the time it takes. I will highlight this part, and I will give you like a Cole's notes, like a short version on your study sheet later on with just quick way to figure it out. Usually this is the time it takes for a full cycle to complete, okay? It is always a positive value. You got to remember that. There's no such thing as a negative period, okay? The midline or median is halfway between the maximum and minimum. And of course, you've got your max and your min. You can only imagine what max is going to reference to. It's the highest point the wave ever gets to. Minimum is the lowest it ever gets to. Amplitude is important, okay? It's the distance from either the midline to the max or midline to the min. And here's my short version for you, okay? I'm going to use a ruler for this. So usually every sinusoidal wave is going to have some sort of line, imaginary line, that represents the maximum at the top. Like it doesn't go past the highest. So I will just go like this. That line represents the max for me. Okay. Then I'll have the minimum. So we're just going to go lower here and draw a line that's parallel to the top one here. This is what I call the minimum. We're going to have to figure this out, but the sine wave will start somewhere, okay? And then we go from there to the next part, okay? Before I do that, let's introduce our midline. Midline, the name says it all. It's halfway between the top and the bottom. Okay, this is what we call the midline. So now you know what the max, the mid, and the min is. Okay? And so let's start on the midline. Can I just tell you something? For us, it's going to be very convenient to start either here, here, or here. Okay? Sure, can you start anywhere else? You may do so. I would not suggest it. But let's say this starts right there. And then the sine wave goes to the bottom. You hit the bottom. And then you go back up. And then you go back down. And then you're going to try to have two hills. But this continues, by the way, and so does this one. It continues either way if it's not a word problem. And here, this is visually, this is what the period is, okay? From here, from a top, the distance horizontally from one peak to another peak. That is what we call the period. Okay? You can also just go and look at two low points and find those two values, and when you subtract it, it's going to be the same. So the distance from the low point to another low point to another low point is always going to be the same. Similarly with if you take two max, right, that is what we consider a period, okay? I'm going to use a different color for amplitude. I'm going to introduce amplitude here. Amplitude is the distance between the middle to the top. This is amplitude. Sorry, it's very small. I apologize. Or from the midline to the bottom, okay? So amplitude is that distance between the midline and either the top or the bottom. So now visually you can see what the max and the min is, what the midline is, what amplitude is, and what the period is. Okay. And so what are some examples of sinusoidal functions, right? I can think of, a swing, somebody swinging. If you go on a swing, that thing just repeats itself, right? You go forward a certain distance, you go back. You go forward, you go back. That's sinusoidal right there. A grandfather clock, right? When it moves the arm back and forth, that's sinusoidal. This one, there's something that we need to assume with a sinusoidal, guys, is that it stays the same. Like the motion stays constant, right? So you will see sometimes examples where somebody's pulling down on a spring and releasing it, and then you have the up and down, up and down, up and down. I would say that's a little flawed because we all know what happens to the movement as time goes by. It goes less and less and less and less until it stops, right? But there will be examples where it says assume that it's constant, like it stays the same, okay? So things like that. Temperatures, if you track temperatures across a whole year, the average temperature tends to be about, it's a sinusoidal wave, right? You go winter minus 40, and then it warms up plus 40, hopefully, at some point, right? And it would do that, right? I can also think of daylight, the amount of daylight. In the winter, you have very little, right? There's the shortest day you ever get to in the winter, and then the days get longer and longer and longer until you get to that peak. June 21st is the peak. And then days get shorter again, okay? So there are a lot of instances where this is the case. Even the tides, right? The ocean tides, they repeat themselves. They can actually you can actually figure out what the tide is gonna be at any given moment, which is very important if you're living on coastal regions, right? To know your tides. It can be a matter of life and death. Okay, so let's see what our equation does. So this is in general what a sinusoidal equation looks like. There's going to be a number here. If it's not there, it's 1. Right? So this is the amplitude right there, guys. It's a number. Okay? If you have the equation, boom, you know what your amplitude is. B, this one right here, it affects the cycle or the period. Okay? C affects, it causes a horizontal shift if you were to change it. D affects the vertical shift. So I have a little note here for myself. I need to, you need graphic examples, right? So I'm going to try my best to do that. So how would you messing with A change your graph? Okay, so this is what I can tell you. If you increase A, like if you make A bigger, you're gonna have something like this. This is my midline, right? This is gonna spread out more, okay? If you decrease A, if you make A smaller, if this is your midline, it's gonna make it be smaller. So you're basically, it's not going to be as tall, as steep, because your A is now smaller. So the distance here and here is smaller. So that's what you would observe on your graph. How does this affect it? If you increase B, you're going to see this on your calculator. You're going to notice that it's like shrinking your graph. It's going to compress it. If you decrease B, you're actually going to like widen it. Okay? So what happens when you increase the value of B, it actually pushes, it's like a harmonica, right? You just push it together. If B is decreased, you're actually stretching it. It's compressing. You stretch. I didn't plan on doing this, so that's why it's not the greatest.
Balraj, please return to room 60. Balraj, return to room 60.
Okay. C affects the horizontal shift. So watch what I'm going to do here. Let's say this is the OG. See how I snuck that in there? OG. My kids are always like, don't do that, Dad. Just let it go. Okay. So basically, you got to imagine if you were to change that value, if you pick any point on the OG, you would shift it this way. And it's as if you're starting here and then you're copying the thing. Okay. So you're shifting. It's a horizontal shift that happens. This is the new one, right? So shifting it will go either left or right, but that's all you need to know, really. You don't need to know a whole lot more for that to help you. And the last one causes a vertical shift. So if this is the OG, this is a record OG lesson, right? If you were to increase that, the whole thing will be shifted upwards. Like the whole thing gets pulled up. Like you just increase that. If you decrease D, it will actually cause everything to go lower. Okay, it'll literally shift everything up and down if you were to change it. And you're like, that's weird to think of shift. Like, what's happening here? In my opinion, if you know what happens when you change it, if you know how it affects your graph, that's how you really know what each component does. Okay, so here it is. Desmos is gonna hopefully provide us with a much better okay, I see. Sorry, I'm just checking something here real quick before I continue. If I have made the changes on your booklet. I don't know my password. Oh, there. Okay, so here it is. I typed in the generic form with letters that allows me to have some sliders, okay? Let's see if I can make this work. So if I were to change A, the bigger A gets, the higher, the taller and lower this thing gets, right? It stretches it both ways, right? Can you see that? Right? This would have been a good time to do the joke about I measured sound waves. It still hurts. Hurts, yeah. B, so B, what it does is if you increase B, it will compress it. Okay? And if you increase B, sorry, decrease it, I should say, you're actually expanding it. Right? So that's what B, so it affects the cycle, because remember, period goes from here to here, right? So if you change B, the period is now shorter. Okay? The distance between peak and peak is less, right? So B affects the cycle, but it's not direct change. It's indirect change, okay? And let me just play C for you here. Look at that. Somebody's on the... We're gonna have some formulas here. So guys, listen carefully. I don't think that, I think you can significantly shorten this, but these are the formulas to determine key characteristics if you are given the equation. Okay? So if you have this equation, okay, if it's y equals anything, you can use these ones to help you find out characteristics about it, okay? The midline is just D. Did you know that? Like this, whatever is back here, that is your midline, okay? Y max, like to get the max, you just go D plus A. Y min, you go D minus A. Does this make sense that, sorry. Pay attention now, okay? This is, guys, let's go on the side here. If this is D, that's my midline. And the sinusoidal looks like this, okay? Would it make sense that to get the minimum, I go D minus A to get to the min? Wouldn't that make sense to you? To get to the max, you would go D plus A, right? So that's what I'm trying to say here. This is important. To figure out the period of this function, pay close attention. I'm trying to see how I can make it clear. The period visually goes from here to here. Okay, it's the horizontal distance from here to here. Okay? But if you don't have a graph, you can find it using this formula right here. Okay? So it's 2 times pi, 2 times 3.14156 and something, divided by whatever b is. So if this throws you off, if you don't want to have the b there, then just put the b underneath. But this is probably one that isn't as self-explanatory, but this is true, okay? This is how to find a period. The domain is all real numbers. or negative infinity to positive infinity. Guys, is this going to be true for word problems? Is this going to be true for word problems? How do you know this is not a word problem? There's no like problem explained, right? It's just why. Range, is range restricted, guys? Yes. Some of you on the test didn't know quite what to do with that one. Restricted is like if there's any stop to it. Like, is there a stop? Does it eventually stop? And this one for sure. So this is what I will say here. I will call this y min to y max. So you'll go to the lowest y value to the highest y value. Or if you want to, you can go y min less than or equal to y max. Can you see that on the screen there? It's a little small down there. But either one of those works. Okay? So I will tell you this. Sinusoidal functions, guys, if you have the equation, you technically don't need to graph anything. You don't even need to type this into your calculator to find out the basics. You should be able to just get it straight from the equation. Okay? So I'm going to ask you to do that on the on page 4. Using the formulas I just gave you. Without graphing. I'm not going to stop you if you really want to, okay? I will eventually do this with you. But can you fill this in using those formulas or the hints, I guess, that I gave you on page 3? Just by looking at this. We all know this is A. We all know this is B. We know this is C. And this is D. Okay? Try to fill that in. Talk to your neighbor if you have to. This is your first mock AC right now. You did it, of course, right? Okay. What is my amplitude? Amplitude is A, which is 5. We don't have any units here, so it's just 5. Equation of the midline. By the way, the midline is a horizontal line, right? So it would be y is equal to, and it's going to be 2. Right? Whatever d is, that's what y is, right? So the minimum is going to be d minus a. So I'm going to go 2 minus a. Watch what's going to happen here. The minimum is -3. The max is midline plus a, which is 2 plus 5, which is 7. The period is 2 pi divided by b, which is 2 pi divided by 0.6283. So you grab your calculator, and that's all you need to do, right? You just type that in. 2, where you know where the pi button is? I don't know if we talked about this. Second hat, like if you second hat activates that pi, sorry. 0.6283. That is 10, right? 10. Can you make sure that on the exam you go 0, 0? Just do that. It doesn't hurt. And then you make sure you don't lose any rounding error. Domain is all real numbers, or negative infinity, positive infinity. What is my range going to be? Any brave volunteer? We actually know. Yes. What's the lowest y value I ever get to? -3. What is the highest I ever get to? Yeah. Kind of looks like a square bracket, right? There you go. Or if you like set notation, not many of you around, but that's how you would do it with set notation, okay? The range is always restricted. You should never have an infinity there, never, okay? Sinusoidal is the one that is restricted on both ends, okay? So now let's try graphing this with our calculator. What's our time here? 2:54, okay? I'm gonna stop here once and then do the no, let's make this part of the one video. Can you type this into your calculator now? And I dare you to not double bracket things. Let's see if you can handle that. Y, clear everything. 5 sine, there's sine there. 0.6283x, don't forget the letter x. Plus 2. I'm going to quickly do one on y2 as well. This is what I want you to see here. Sometimes students do this. I don't know why. I'm trying to figure it out. Just like I'll figure it out at some point, probably when I retire. You see that double bracket there? Some students do it by mistake. I think it's a different graph, so I'm going to make sure we graph it. Pay attention to this part. Before I graph it, do we know our window parameters? Can we like adjust our window already to make sure we see it? I think so. Let's go to window. Yeah, we know the min and max. We know the y min is negative. That's -3, right? So what should you put in here? I'll go -5, okay? The lowest y value is -5. What about the highest? 7, right? I'm going to go 10. And let's hit graph. So basically what I did is I used my max and my min to adjust my y min, y max. Let's hit graph. This is what I see. Did you see the red one? Did you see that? It's a completely different graph. Let me try again. I'll just change this to 4 and then back to 5. I think then I will regraph it. So this is the one we're supposed to have. That's the one you would get if you double bracket, okay? So please don't double bracket. That's your warning right there. So I'm just going to do this. Pay attention to this part. It's going to make your lives a lot easier. Is it necessary to see this many cycles? No. Usually 2 cycles is all we need. So watch what I'm going to do. This is going to be a good trick for word problems. I'm going to go to my window. X min, I'm going to have -4. I'm going to leave it at that. X max, watch what I do. I want to see 3 cycles, more or less. How much is a cycle? You see that? Period is, that's like how much it takes for one full cycle. I'm going to go 3 times whatever the cycle is, whatever the period is. If you go enter, it's going to be 30. You could have just typed in 30, much easier. Now hit graph. Okay? So you're like, Mr. Erickson, I can see more than 2 cycles. Yes, you want to see a little bit more, but from here to here is 1 cycle. From here to here is a 2nd cycle. And you actually see a 3rd cycle. So sometimes you'll see 3, sometimes 2. But if you do the trick that I just showed you, change your y min and your y max based on your min and max that you figured out from the equation. Then this one, I would go a little bit into the negatives. The x max, I'm going to go 3 times whatever the period is. Listen to this. Sometimes a period is 0.13. It's a very, very small period. But still, go 3 times that, and then your window will show you just a few waves. You don't want to see as many waves as you can, right? So this is a good graph. Okay? Where are we at? 3 o'clock. Are you gonna be able to do this? I think so. Yeah, so let's actually graph this now. And I will tell you this, my booklet has like fancy schmancy like steps, how to do this. But I think I'm just gonna get right down to business and just show you a very simple way to graph, okay? So this is what you do. I'm gonna find my starting point. However, I want to be very strategic here. Do you remember the 3 lines? Do you remember? The max, the mid, and the min? Okay, remember that? I wanna land right on one of those. Okay? So what I'm going to do is I'm gonna start on a max here. That's gonna be my choice for my starting point. I'm going to start at a high. So grab your calculators. You ready? Second trace max. I'm going to trace this back until I get to this max right here. Ready? You go to the left, enter, then you go to the right, enter, and then enter one more time. Get that coordinate. Write it down. Negative 0.28, sorry, 29, right? Sorry. Seven. Got it? Negative 0.297. So this is going to be 5, 10, 15, 20. I think this is going to work for me. What's the highest I get to on the Y? Anybody? 7, right? So if I go 5, 10, then I'm good. And I'm going to go -5 here. And you will develop your own way to graph, I'm sure of it, but I will show you the one that I would recommend. Okay? And what I tend to do is I take my ruler and I graph a light line on the 7 along y is equal to 7. So you can make it dashed. It's not necessary, but it makes life a lot easier. Then you go to -3, because that's the lowest I ever get to. And I also make a light dashed line along that one. So I'm between these two lines here, this one and this one. This is y is equal to 7. This is the line y is equal to -3. So the first point is going to be where? -2.29, which is right about there. Just close enough is good enough. You got it? Let's see if you were paying attention. What will the next peak be? Where will the next peak be? What is a period? From here to here, it's what, 10? Remember the period was 10? So what do? You go -0.29, that's my x value. You go plus 10. That's 9.71. So your next point is going to be at 9.71. This is 9. This is 9.5. 9.71 is right about there. So to go from here to here, I added 10 to my x value, right? This is -0.297. And I add a 10 to it, so this is 9.717. Okay? How many units is it going to be to the next peak? How many units? 10. Thank you. So can we do 9.71 plus 10? Yes. That's going to get me to 19.71 right there. Please don't do the wave thing that I'm doing right now on your actual graph. This is just for your notes. Okay? So hill, hill, hill. Now we got to do what? Now we got to figure out the valleys. I'm only going to find one valley, okay? Only one. So this would be 19.717. I'm going to slow down a little bit so you guys can follow, right? Let's find, this is my peak that I started with, okay guys? I'm going to find the first valley right after that peak. I'm going to find that valley. I'm going to find the lowest. You go second, sorry, come on, second trace min, go find that low point. You go enter, enter, enter. That is 4.71, negative 3. No surprise it's on the negative 3, right? 4.71 is right here. So go up here on the side here. I'm just going to show you that this one right here is 4.71, negative 3. Okay. Guys, how many units is it going to be till I see the low point again? 10, right? Yeah. So I'm going to take this, add 10 to it. So what would that be? 4.71 plus 10 is 14.71. So this is 14.71. Let's connect the dots and see if this is going to be an acceptable graph. So I go up from up here. Please don't go straight. It's not zigzag, okay? It's sinusoidal wave, right? So you go here and then you go out and down through that point. And you go up through that point. And you go down through that point. And then you go back up through that point. And then you go just like that. Okay, just extend it a little bit, make that turn, arrowhead from there. I'm going to go back to my starting point and just go in reverse a little bit and just introduce an arrowhead there. Two-fold cycles. This is considered two-fold cycles. How do you know? 3 peaks or 3 valleys will do the trick for you. 3 peaks means you go from this peak to that one, that's one cycle. And this is another cycle. So you've got 2 cycles. I will say this, 2 cycles, 3 peaks. Okay? So this is how you go from equation to graphing. Okay? I'll say this. The fastest way for me is start at a high somewhere, add the period, boom, you got that. Go find the low point, add the period, that's it. Like you don't, as soon as you have 2 full cycles, like if I could cut this here, this would be 1 cycle, right? This thing. And from here to here is another cycle. Okay? So that's how you do the graph. I'm going to ask you to try this. Yeah. Yeah. I want you to try page 7 to 8. 2 questions. You should try not to leave without having done one today, okay? try at least page 7. I'm here to assist you. I'm on your corner. What I would suggest every time before you get started, and I'm kind of preparing you for it, I'm asking you to first fill out this kind of inventory here. Based on this equation, you fill in this, and then you proceed to graph. Okay? I know it's a little overwhelming. One step, baby steps, right? Baby steps. You got it.